So let us start the chapter 1, module 3 of our e-learning content. Okay. So this is what we are going to study: codes, standard, and specifications. So let us start with first code. Okay. This is a really interesting thing. Why at all we require code? Whether code is there to make our life simpler, or is it there to make our life more difficult? Okay, many times we feel why these things are required. We already know that PD/2T formula. Why not use that and calculate the thickness of a cylindrical shape? Why we need code? Okay, so anybody can answer that in very short. Why we need code? You can just answer in chat box. Don't need to open the mic. Just answer in the chat box why we require code, and whether our life will be much simpler if we don't have code, or it will be more difficult. Okay, let us first answer that. So with easy or difficult, just write easy or difficult, whatever you feel. Our life will be easier if we don't have code, or it will be difficult if we don't have code. Just write in the chat box. Quickly, guys, quickly, just write in the chat box. That is the energy which, see, I'm just talking to a screen. Okay, so I'll not get energy if you don't respond. Okay, I need a reply so that I know that you are engaged with me, and then we can continue. Okay. So Muhammad is saying it will be easy if our life will be easy if we don't have code. Sanjay Sharma is saying it depends. Okay. Vivek is saying easy if we have code. Okay. So that means it's difficult if we don't have code. Okay. Great. What about others? Anup is saying, see, easy. When I say easy, if we don't have code. So easy. So Himman's is asking if we have the code, it will be easy and standardized. Okay. Difficult if we don't have code. Okay. So most of you are saying that our life will be easy if we have code. Okay. That is how I think we have understood that if we have code, code is made to make our life more easier. Okay. If we don't have code, it will be really difficult for us. Now let us understand this with this case. That if I have have to design a cylindrical shell. Okay. And then if I don't have code, I know a formula, right? PD/2T we have studied in engineering. Okay. We don't know about others rules. So can I apply this PD/2T, or if I apply this PD/2T formula, what is that I am missing? Why I cannot apply this formula? Anybody can tell that if I apply this PD/2T formula, what is wrong in that? Come on, guys, let's make it a kind of discussion. Okay. Just tell me if we apply PD/2T, what is that I'm missing? Why I cannot apply? Or if I apply, it will be good enough, or anything additional I need to build. Guys, come on, respond. Okay, so Sanjay ji is saying welding joint weakness. Correct. That is a very good point. So see, in PD/2T formula, we are not considering that welding part at all. Right? We are considering this as a complete solid cylinder, a kind of completely theoretical thing. Right? It's not practical. We are not making this shell from forging. Right? Many times even we may do that from forging also, but again, the designs also we need to connect, right? So welding is going to be involved. We cannot make a complete forged vessel, right? Welding will be involved. So that is what is missing. Okay. And then just saying manufacturing defects, right? That is also related to welding. Asin is saying joint efficiency. Yes, that is also related to welding. So mainly it's coming like that welding part is completely ignored, right? What else? Anything else which is missing? So welding we understood, and welding is related to all the things like manufacturing defect, as Sanjay ji is saying, and joint efficiency. which Haseen is saying, right? What else apart from welding? Stress intensifications. Okay, but Sanjay ji, we don't consider stress intensification for Section 8 Division 1. Right? Section 8 Division 1 only talk about primary stresses. So stress concentration or secondary stresses, the thermal, they don't come into picture. Okay. So what else, guys, apart from the welding, nozzle opening? Yes, there will be nozzle opening and there is formula available for that. But let us focus only on if I have a cylinder and if I use a PD/2T formula, am I missing something in that? Yes, Munendra has very rightly said, allowable stress. Okay. See, when I'm calculating, yes, Anup is also saying same thing. So see, if you see that formula, what we are trying to find out, whether we are trying to find out stress? No. The formula we'll have to rewrite as thickness is equal to PD by stress. Okay. So actually, I'm trying to find out thickness. Okay. I have pressure given by my client. I have the diameter also given by my client. Okay. But how I will find the stress value? Okay. Now let us assume that we don't have code. So how we will be able to decide what is the stress value? Is there any method if I don't have code? Can I decide what will be my the stress value? Let us forget allowable stress comes when the terminology is used in Section 8 Division 1. But if I don't have that, what stress value I will take? Okay, just forget, just ignore that we don't have code at all. We have not heard of code. If you are just out from a college, okay, and you have given this assignment, okay, you have to find out thickness, you have pressure, diameter, you have the material also available with you. Okay, how you will proceed if I don't have code? How I can calculate the thickness by using this formula, because there are two unknowns here. Assume based on different sources. Okay, but the assumption is going to be really dangerous because we are going to design. So if our assumption is wrong, the vessel will fail. Right? What about others? What do you feel? See, because there are two unknowns here, stress and thickness. I cannot find thickness if I don't have stress value. So what this stress value you will consider if you don't have code? Material test certificate. Rajshekhar is very good. So I'll take the material test certificate, and in that I'll have lots of values. What values will be given in test certificate? There will be yield stress, there will be tensile stress, right? So, but in that yield, it won't be allowable stress won't be given in that test certificate, right? So I have two values now, which is known to me because I have referred the test certificate. So there is yield stress and there is tensile stress. So among these two, or by using these two, how you will find this stress? Or you will directly use tensile stress as a stress value and then calculate thickness. If I do that, then I'm doing it correct or doing it wrong. Just write correct or wrong. What I said that I'll take that from test certificate, I'll take the tensile stress value for that material and use that in this formula to calculate the thickness. Am I doing it wrongly, or I can do that? It's correct. What is this? So Vivek is saying wrong, wrong. Yes, so Shinja Sharma has pointed out that no factor of safety, because if I take a tensile stress, so if I'm taking that material, if you remember that stress strain graph, so that tensile stress is the end point of that material, right? Before that, that yielding point will come where your material, your vessel will yield, it will deform, right? Because the strain is very high at that portion. So you don't want your vessel to be deformed, right? So now let us come back. If I cannot take tensile because it is allowing that material to get deformed and there is no factor of safety, then can I use yield because yield is at lower point. So can I use yield stress in this formula and find the thickness? Can I do that? Just say yes or no. Can I use yield in this formula and calculate the thickness? Yes, no. So Sanjay Sharma is saying no. What about others? Why I cannot take yield, or I can take yield, whatever you feel? Just reply, guys. You all are there. I'm expecting reply from all of you. Okay. And if you cannot reply, then just want to listen, then it will not help you. Okay. So just get involved, because that energy will be reflected to me also, and also will be excited to talk. Right. So temperature, yes. Okay. So yes means I can use it, right? If you're saying yes, means you're saying I can use yield stress, or I should use yield stress, right, Rajshekha? Sanjay Sharma is also saying temperature. Yes, temperature is also very important. We'll come back to that. So Rajshekha is saying yes, we can use yield. But if you're using yield, so if you see that yield point, a little deformation happens for that material. Okay. And like Sanjay Sharma is mentioned, we don't have any factor of safety there. Okay. In mechanical engineering, we don't design anything without factor of safety, right? Because whatever parameters are given to you, like design pressure, temperature, all this can vary a little. Okay. So if it varies a little, I should be able to take care. Okay. And there are lots of additional loadings also. Okay. And the stresses, like Sanjay Sharma has said, that there are some stress intensities. Okay. So we are not taking account that when we are doing that design by rule calculation. Okay. We are just doing the primary stress calculation. Okay. Now, if you are wondered what is primary stress, what is secondary stress, what is peak stresses, then we'll have one more webinar, and it will be focused on that which part we have primary stresses, where we have secondary stresses. So in section 8 division 1, we focused main by design by rule, and by design by rule, what we can calculate is primary stresses. Okay. So now coming back again, so if we have yield stress value, we are actually allowing that pressure vessels to yield. But that is not, we want to use that for 10 years or 20 years, whatever is the life cycle. Okay. We don't intend to use it for only one cycle, right? So we need our vessel to maintain its shape, right? So if I'm allowing till yield, it will yield and have a permanent deformation, which is not at all acceptable. Okay. So definitely I need to have some factor of safety built. Okay. Now, if that is left on the fabricator to select the factor of safety, there will be lots of different factor of safety considered. So for same parameter, we may get different thicknesses proposed by the fabricator or the designer, right? There is no control. So we need someone to specify what factor of safety should be applicable, isn't it? So that is where your code comes into picture. What factor of safety should be taken? Okay. So these two parameters which we found, that one is related to weld, the joint efficiency, what type of examinations you should have, and the second is that factor of safety part. So these two parameters are governed by code. That is where code comes into picture. Okay. And we have different factor of safety given by different codes. Okay. It's not like each code is having same factor of safety. That is where the code also mainly differs. Section 8 division 1 will have different factor of safety. Section 1 will have different factor of safety. Section 3 will have different factor of safety. That is where actually the code differs from each other. Okay. And also the examination, what examination is required. Section 3 will be much more critical lots of examination will be required because that is related to nuclear, right? So it is really critical. So there will be lots of examinations. If we are designing something which is not very critical, we can even do away with very less examinations, right? So that is the two things which we are listening now as related to like examinations. Lots of things are involved in that, because if you are doing welding, that how to qualify that welding, okay, then how to do the examinations, all these things will be given by code, okay. So that is how this code is different from a normal design. And if we follow that, we are following a guideline which is followed by each and everyone. Lots of equipments are running on that design code. So we know that it's proven, okay, because when something happens, we will be able to evaluate how it happens, because we are following same procedure. Each and every step is controlled, right? If we don't have a standard or code, we don't know what steps to correct. Even if we find some problem, if we find some failure, we don't know from where to start, which stage we gone wrong, because each one are following different rules, okay. So that is why code is a really important document as a design engineer, and it's a kind of gift to us, so it's really important when we talk about codes. So we have different codes for heat exchangers. The pressure vessel code is same, but then we have TEMA standard. Okay, we'll talk about standards also. The pressure vessels, spherical tank, lots of different kinds of equipment, columns. We use code to design them, right? Now let us talk briefly about standard. Okay. Now anybody can try to explain what is the difference between standard and code, because many times we get confused with this word. What is standard and what is code? I need reply from most of you. At least 80-90% should reply. Whatever you feel. There's nothing wrong or right. We are all here to just discuss, So just try to evaluate with your point of view. What is standard and what is code? What is the difference? If in one sentence, if you can write, okay, I'd like to see your response. Come on, please respond. Yes. So Muhammad is writing, centers are set by the people of particular location and for particular reason. Okay. Standards differ from company to company. Okay. Code is set of rule. Code is mandatory. Okay. What else? Good. We have crowd which actually fairly understand what is code and the standard. What about others? Please respond, guys. Okay, because I can see only few people are responding. One code remains same for all. Okay, I don't know what you mean by that. One code remain same for all, because there are different codes followed by different reason. Like America was following ASME, which is followed by most of the countries, but then European has different, Germany has different. ASME is same for, yeah, if we are following a particular code, then it is applicable for complete part. Okay, so that will be like if I say ASME section 8 division 1, then I have a particular code which I have to follow for each and every step. Okay. So code is set of rules to follow, while standards are reason based. Okay, codes are compulsory requirement. Okay, good. We'll discuss about that in detail now. Let us take a small example to understand that why, first of all, standards are there. Okay, we understood why code is there. Now let us see why that standards are coming into picture. Okay, we have two people here. Okay, you can name them as Ram and Tia. Okay, So Ram is traveling, okay, from a point which is red to a green point. Okay. He covered that distance in 90 steps. Same distance is covered by Tia in 100 steps. Okay. Now, if I ask them, what is the distance between these 2 points? If I don't have a standard unit, okay, then Ram will say, I covered in 90 steps. Tia will say in 100 steps. If someone is taller or shorter, these steps may vary for them, isn't it? So in the early stages, we used to make these kinds of standards. Okay, but the flaw with these standards, whether they are not consistent. Okay, we need a consistent standard, like a consistent unit of length. Let us take an example. And if I'm talking about weight, then a consistent unit of weight. Like if I say some value, it will be the same value across the globe. Okay. So if I tell a distance in meters, let us say 50 meter, that is a fixed value. Okay, that does not depend upon how I measured it. Okay, because 50 meter is a standard value followed by each and every person in the world, right? You may have some conversion unit, but then the relation of conversion is also fixed, and we get a fixed value, right? So if I say 100 kgs, across the world, people will be able to understand what mass I'm talking about. Isn't it making sense? So standards are made, like the name itself, that standardization of a unit, okay, or a component, right? If I have a standard pipes, how easy to manufacture it and purchase it, right? In compared to if I have a shell, we always struggle. We have to roll, start from procurement of plate, roll. If I have a standard pipe, we know what is the OD, what is the, if I have a specified schedule, what thickness I'll get. Okay, so everything are fixed. I can just select the pipe from the manufacturer and use it. I can select a flange, directly procure. If I don't have a standard flange, then how complicated that process becomes. That's time taking, and money also will be involved. So cost and time, both will be more, right? So that is where the standards comes into picture. If we have everything standardized, it will be much easier for everyone to follow, right? Fabricator can make with that standard, and then whoever is going to use he will also design his system based on that standard, right? Making sense? If it is making sense, please say yes. Okay, if you have any query, please note it down. You just make I hope you guys are using a notebook, because you will have definitely lots of takeaways from this. So take a blank page and write a parking lot where you can park your questions. Okay, and then at the end of the session, we'll take all the questions. We'll keep discussing. Okay, so don't worry about that. So if you have understood the concept, please say yes in the chat box. Yes, if you have understood what is the standard, why that standards are there, great. I have few yes. Okay, so now let us understand the definition part of it. Okay, see, it's difficult to remember the definition. Mainly in mechanical engineers, we are mainly focused on what exactly it is than the definitions. But when you're reading codes, definitely the definition is also very, very important, right? So the standard is a kind of set of technical definitions and guidelines. Okay, how to instruct, whatever we think, how to instruct in a proper manner so that other people will understand. Okay, and there not be if and buts in that. Okay, there won't be any confusion in that. So that is how the standards are created. Okay, so there are lots of different standards, some related to like ASTM, almost all of us follow. That is a standard for materials, And that ASTM is also taken in ASME. Lots of material are taken. ASTM also takes materials from ASME, okay, because ASME material is mainly fixed on boiler and pressure vessels. Okay, ASTM works on lots of different varieties of material across the industry. Okay, so then there is ISO. Everybody knows what ISO is. It's mainly focused on the quality system, how whatever process we are doing or services we are doing, okay, how to control that process and give a quality output. That is where ISO is focused on. So if we follow these standards, our quality will be very high. Okay. Then there's API, MSS, IS. IS is Indian standard. So lots of standards are there. TEMA is also a standard. It's not a code. So that TEMA is related to heat exchanger, right? Lots of guideline is given. So now what is the difference between code and standard? See, code in many countries is a legal document. Okay, if you have said that you are following ASME Section 8 Division 1, okay, like if it's a use stamp and you are signing the design report, then you are responsible for anything happens, to that vessel. If some mistake happened, then you are the person who is responsible and you can even go to jail for that. Okay, if something happened. So it's a legal document in many countries. Okay, like USA, it's a legal document. You have to follow use stamp. Okay. In India, based on client requirement, there will be, if they require use stamp, we'll provide use stamp. Otherwise, we will follow the same set of rules. Many times we get confused what is use stamp and what is normal design. So design wise or fabrication quality, there is no difference at all. Only the difference is in use stamp, we'll try to create document for each stage, because then you have to show the proof, right? So steps are completely same, but now because you are saying that you are following use stamp, you have to create all the documents and you try to follow all the process because somebody is there to check. Okay, so that is the only difference. Otherwise, there is no difference in rules and regulations. Okay, Sanjay Sharma, can we say code is a guideline for those process which cannot be standardized? It's difficult to say it like that, because these are also, uh, it's not like, see, because if design rule is formulated, you can call it as a standard. It is made for all the type of things. So, but normally standards are somehow, I think I can relate with what you're saying. Okay. Okay. So standards mainly are made to make our lives much easier. We can produce certain kind of dimension, certain kind of product with that standard, and it will be valid for all type of applications if I am using it. Okay, great. So let us move on. And the third document is specifications. Okay, so specifications, many time we prepare, and that are very specific to a client. Okay, based on their practices. So it's kind of very local. Okay, completely related to that specific project. It may change even project to project basis. Okay, so if certain guideline, we want to pass it on based on our engineering judgment, our experience with that product, that we try, and it is not there in code and standard. If it is there in code and standard, we just have to say that refer this code and standard. We don't have to prepare specification. So if certain guideline, which we feel that it's important for us as a client to take care of the quality, it may be even stringent than code. We cannot relax the code or standard requirement, but we can make it more stringent. Okay, hope you are getting it. So specification is kind of additional requirement based on our personal experience, the customer or client, that organization personal experience, whatever they have felt, whatever they have used for so many times, and they want to make that job as a specific to that. Okay. So there, that specification comes into picture. Okay. Now, see, just take, if you take an example, if I have to make a building, okay, there will be lots of different materials required. So like a reinforcement bar, that, whatever is required, if we are making a specification, we may even state the brand, like these are the 3 brands among that which you have to select. That becomes a specification, right? For cement, what quality, if something additional you want, some company's name you want, if you want to specify, that will be part of your specification. Okay. So that is how that specification goes. Okay. So specific or additional requirement for a material. Okay. So that is definitely beyond the code. If it is already there in the code and same thing you want to say, then it is not required. Okay. Because it's already taken by the code or the standard which you have mentioned. So normally it is created by that organization, specific organization, which is giving you the order. If you are the client, you will be making on behalf of your organization. Okay. So I hope that is clear. I'll just quick comparison between these 3 that will bring more clarity to you. Okay. So code is actually enforced by law. Okay. But standards are a globally acceptable norms. Okay. For ease of fabrication, ease of cost. Okay. Specifications are very specific to the contract, to the particular project. Okay. Codes are a governed body. Nobody can just come out and make codes. These are actually governed bodies. Okay. So standards are also written by it may be even public organization, okay, or government organization. Okay. But there will be controlling on that, because it has to be a worldwide organization. Otherwise, if you are making a standard which is very local, it will not have much significance. Okay. Specifications are written by the organization. Code will have, like, if I have a design code, okay, let us say section 8 division 1. So starting from the procurement of material, how to procure material, what type you should have, what are the additional requirement for that material, to the end supply, including design, fabrication, welding, each and every stage, how you will be performing, what are the requirements. It will cover all. Okay. It will not be very specific to some product, while standards are very specific. Like heat exchanger TEMA is applicable only for certain types of heat exchangers. Okay. So very specific field. Okay. Specification, it can be definitely, for each and every product, you can write a specifications. Okay. Some examples like, for code ASME, which is American, British standards, or DIN, which is German. Then standards like TEMA, ASTM, ISO, these are the standards. Specification, like you might have referred Shell DEP. Okay, that is written by the organization Shell. EIL specifications, many times you might be using for design. So that is also very specific to products.